Hey guys, welcome to Objective 1.5, Implement Exception Handling. Today's objectives cover how to handle exceptions, throw exceptions, and create custom exceptions. Alright, so to get started, we first need to understand what an exception is. If this is the first time you're seeing exceptions, then this will be new for you. An exception in C# is a type of error. Now, it's not just an error message. An exception is actually an object that has a bunch of information about the error. So it not only just has an error message, which it does, it has maybe where the error went wrong, like what line it was on, and some information like that. We'll get into like what other information it has later in the lesson. So to start off, we're just going to look at listing 1-88, and this just provides you with an exception. It just shows you an exception, what it looks like, and before we actually fix it and manage these exceptions and how we can deal with these exceptions, it just wants to show you what an exception looks like. So it's pretty basic. They just create a string, and they say S. Now, this could have any value in it. It doesn't really matter. And what they're doing to try to get this exception is they're just trying to convert the string by parsing it to an integer by going int.parse S like this. And we all know that if I parse hello into an integer, it's not going to work because we can't convert hello to a number, or hello is not a number. So if I run this, we'll see I get an exception. And the program crashed, and I get a format exception, and we get some information along with this. The input string was not incorrect format, so like that's like the user-friendly kind of message right there. We also can get a line number. If you see line 15 right here in my program.cs, that's where it is right here. We can see that on line 15, that's where the parsing would happen. So that parse can throw an exception, and that's where it happens. So we can see line 15 there, and you can see some other things with the information about the call. So yeah, so that's what it looks like when an exception gets thrown. Now keep in mind, if an exception gets thrown and we do not handle that exception, the program will crash. So any exceptions that are thrown, when we program things, we need to program in a sense of mind that we need to be wary about. Okay, does this throw in exceptions and will this ever throw an exception in my, like, is there ever a situation that this could possibly throw an exception? If there is, we need to manage it and handle it and determine what we want to happen if it does throw an exception. Okay, so the way we write code to prepare itself for exceptions and how we manage exceptions, we use a try catch statement. Pretty much what we do is anything that can potentially throw an exception, which is this parse. Now, also to note, which is kind of cool, is if you highlight a function with Microsoft Visual Studio, highlight a function, it will tell you the possible exceptions that can be thrown from this function. So as you can see, this exception, argument null exception, format exception, and overflow exception. These are three exceptions that can be thrown. Now we can catch, or we can manage our code to be cautious about all three of these exceptions, but we'll show that in the next listing. This listing we're just going to deal with the first exception, which when we ran this, we can see what kind of exception do we get. We get a format exception, which means that the input string was not incorrect format. So it means it was kind of like an invalid value. So to fix that, we're going to surround our code that can potentially throw an exception in a try block. So there, we put in try, and after the try, we're going to catch. And inside of our catch, we're going to say which exception we're trying to catch. In this case, I'm trying to catch a format exception. And I'm just going to leave it like that. I'm not going to put it in a variable just quite yet, just so you can see what happens. So now I'm saying, now I created code that is aware of a format exception being thrown. And now in here, now I can program if that does happen. So I'm going to say invalid value, just like that, so you can see what happens. Now when I run the code, you can see that it says invalid value instead of crashing the program. Now, if I had code down here that kept on going on, let's put TTT, you would see that the TTT still shows. So I caught that exception, I managed the program, and my program keeps on going. If I didn't have the catch, the try and catch in, and I did this again, we could see that when it crashes, I never see that TTT anymore. So by managing that, by managing the error, I can manage it and then continue on without having the program crash. So once again, just to reiterate, you put the try block, which looks like this, around the code that could possibly throw an exception. After that, in the catch area that comes after the try, you list the possible exceptions that can be thrown. So in this case, I'm just looking for the format exception, and I'm catching the format exception, and then I'm saying invalid value. Now, I can specify a variable. If I say format exception E here, now E is representing the exception that was thrown. Now, by doing that, I can use E and access more information about it, the exception. So if I go E dot, we can see this is all information about the exception that we have. We have a help link that Microsoft provides. If there's an inner exception, meaning that there's an exception that came before this exception, and we just kind of attached it. We'll get to that, I think, a little bit. A message is the friendly message. The source, oops, I didn't mean to do that. The source, the stack trace, which we'll see it a little bit. The target site. So this gets the method that throws the current exception. So we have a bunch of information about it, some data. But I'm going to show you the message. So it's going to get a message that describes the current exception. So I'm going to plug in the message like this of the exception. And when I run it now we see invalid value. Input string was not incorrect format. And that's what we got when it crashed and we didn't manage it. But now I have that message and I could use it like this. So this is the basics of catching an exception. Now I want to jump to the next listing, which is listing oh, well, this was 8.9. Now we're going to 9.0. And listing 1-9.0 is catching different exception types. So catching multiple exceptions. So the first thing to know about when we catch multiple exceptions is that we just list the catches following each other. But it's important to note that we want to list the exceptions from most specific to most general. So the most general one would be at the bottom, and I'll get to that a little bit. But if you remember the parse, it throws also a argument null exception. So I'm going to catch that as well. So by doing this, I'm just going to go catch right below my try. I'm going to catch an argument null exception like this. I could put my variable. So if I go like EE, just go like this. Just copy. Hold on. Null exception. And then we'll get my EE.message. Now, an argument null exception gets thrown if it's trying to parse something that is null. So if I make this null like that now, so S is null, meaning that there's no value has been set. Now the null exception will be thrown because I'm trying to catch that also. So I can list my catches following each other just like this. Catch this exception, catch this exception. When it does the try, if an exception is thrown, it tries to match it. It says, is this the exception that was thrown? No. Is this the exception that was thrown? Yes. Whatever it was, and then it would do it like that. So if I run the program now we'll see. So now we see that when it says null exception, we get value cannot be null. So the argument null exception was the one that was thrown, not the format exception in this case, because the argument null exception called it first. Now, just on a side note real fast, just for your information, every exception has to derive from a class called system exception. So if let me see if I can go to definition. No, okay, it has a bunch of stuff. I'm not going to get into that. So every exception has to derive from system exception. So the most general exception always is just exception. Catch exception. Exception because every exception derives from exception. So this, if you want to always specify this will catch any exception that is thrown. Would always be caught in this general catch exception. So to quickly show you how we could use this, let's go ahead and delete this real fast. I want to show you. So if I highlight the parse function again, it says the last exception that can be thrown from this is an overflow exception, and that means that the string has a number that's so big that it can't fit inside of an integer and it overflows, so we'll throw an exception. So if right now I'm catching argument null and a format, so if I do this, I'm going to put a really big number in here so it overflows. If I do this, try to parse this now, I'm going to get an overflow exception. When I run this, we'll see it crashes. System overflow exception value is either too large or too small for an int 32. What an int 32 is by default is an int. Shows me line 18 and blah 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 parse, and it tries to do system.number.parse int 32, and that's where it crashes. So it's crashing. Now I could implement a catch for overflow, but I just want to show you how the general catch exception works. So exception, I'll say, I don't know, E1. I just want to show you the message. So E1 is my new exception. Now I'm going to go console.writeLine. I don't know what happened. I don't know what the message was, so I'm just going to say exception. In this case, because it's general. And I'm going to plug in the E1.message, and let's see what happens. Now, so this is a general exception. It will catch any exception. So I'm not specifying an overflow exception, but an overflow exception happens, so let's see what happens. Now, as you can see, I just wrote exception because I don't know which one it was, but the value, I got the value of the overflow. Value was either too large or too small for an int 32. So I caught that exception using the general exception right here. So I'm not specifying that it was an argument null, a format, or whatnot. I'm saying catch any exception. So I could remove all these, and whatever exception it is, it will catch it. So if I change this back to hello and run it, we'll get that input string was not in correct format. So that's a little bit about catching different exception types and a little bit about the exception class itself. So another cool thing, oops, let me fix this. Another cool thing that I want to show you is the finally block. Now the finally block is a part of a try catch, and it's really simple. The finally block just says that if an exception is thrown or whatever happens, it doesn't matter if an exception was thrown or not, if you specify a finally block, the finally block will always execute its code. So if I put finally here, and then I put some code in here, I'll say console dot write line always executes. So in this, I'm saying the finally block is always going to execute. So in this example, the argument no exception is going to be thrown, and then the finally block will still go off always. As you can see, always executes. Now, even if there is not an exception, so like this is not going to throw an exception now, the finally block still always executes. So that's one thing to note. If you specify a finally block like this, the finally block will execute if an exception is not thrown, or even if an exception is thrown. The purpose of a finally block is to do, like if an exception is thrown, you want to do a last minute thing, like you want to deactivate something or do something else. Whatever it is, you can put it into the finally block, and if an exception is thrown, that code will happen. Now, the book specifies that, it says that, there are exceptions where the finally block will not run, and that is, if the try block's in an infinite loop. Okay, well, obvious, then it won't run. And it also says, like, if there's a power outage. So I don't know why it really wanted to do that. I mean, those are common sense. If there's a power outage, nothing's gonna run on your computer. So I don't know why it really wanted to say that. Whatever. But yeah, for the most part, a finally block will always run. So that's a finally block. Now, really quickly, I'm not gonna write the code for it. In listing 1-9.2, it specifies that there's an environment.failFast. And the environment failFast pretty much just, okay, so the environment.failFast function, if you use that, it will just overwrite and not run the finally. So if you do environment.fail fast, it will just close the program, stop it there, and it will not run the finally block. So that's if you want to get around it. And the book says, if you have a situation in which shutting down an application is safer than running the finally blocks, then that would be a good opportunity to use environment.fail fast. So that will, if you do that, it won't run the finally section. Okay, I just want to quickly read something real fast. Just quickly, if you do have the book below listing 1-92, there's a table 1-3, and it just shows you some of the properties of system exception. And that's what I was looking at with the message and things like that, which is right here. So instead of a message, there's other things also, like, for instance, stack trace. And a stack trace is a string that describes all the methods that are currently in execution. This gives you a way of tracking which method threw the exception and how that method was reached. So if I go ahead and do that for this, so we can see what it looks like. Let's see. No, I want null. So by doing this, this is what I get. This is the stack trace. So it shows me the information. Notice how the finally block is still running right here. We get null exception, and then we get the stack trace. So it shows what functions were in execution. So we see this function, and then we see int.32 parse was in execution, main, and at main, and we can see it once again, the line number right there. So that's some information about the stack trace. Okay, so I wrote out this code quickly. I just want to show you this real fast. So in listing 1-94, we start talking about throwing exceptions. So what does it mean to throw an exception? Well, maybe there's a couple of different reasons why we want to throw an exception. The first one, they give you an example right here, throwing an argument null exception. In this case, we did a check, right? We have a function that open and parse that takes in a string file name, and we check the string saying is null or white space. If it contains either of those, then inside the if statement we say throw new argument null exception, and then we pass in some information about it. And you'll see that here in a second. So the first thing what we're doing is we're doing a standard if statement, and we're saying, if this happens, then we'll do something. By throwing a new argument null exception, this throws this up to the caller. So if this happens inside of this function, we'll throw this exception up to the caller. So now this right here has the possibilities of throwing an argument null exception. So that's what happens in the real world. This is how the errors are happening from Microsoft and things like that. Now I could add in some comments and things like that could specify what exceptions can be thrown. But now open and parse is prone to having argument null exception thrown. So to throw an exception, there's a couple ways to do that. I'll show you two of them and explain a little bit of differences, but you can read them in the book. The first way is we could say, well, actually, before I get to that, we say throw, and then we say we need to throw an exception. So the first thing we're going to do is, in this example, we say throw new argument null exception, because remember, an argument null exception is just a class, it's just an object, and we need to give it memory, allocate some memory for it, etc., things like that. So we need to say new. We need to instantiate the object. So that's why we're throwing a new argument null exception, and we're calling the constructor of the class. So that's what's happening here. And so pretty much we're just creating an exception right here, and then we're just throwing that to the caller. So if I ran this code, you'll see that we get an exception now because I passed in null to the function, and I get an argument null exception, and we can see the parameter name is file name. I passed in that, and the argument null, the message that I passed in its file name is required. So I passed in some custom information about this exception. Now I can just catch this because I have now it's throwing an exception. I need to catch it up in the caller. So argument null exception console.writeLine argument null except and I'm just gonna put in e.message. So now we can see I catch the thing, and now we can see the parameter name, file name, and argument null exception file name is required. That's the message that I passed in. So by throwing an exception wherever I am in this function, it throws it to the caller in this example. Now, this is one example. Now, there's a couple other ways I'm going to quickly talk about. Actually, the only other way I want to really note is, because I think this is important just to remember, is if I can throw an exception just by saying throw. But in order to do this, I need to be throwing from another catch. So if I have a try catch, right? Let's say I have a function just like this, and actually we could use this example a little bit. Hypothetically, if I wanted to do this, it really isn't that smart. Open and parse through an exception. It threw it back to the caller. So on the caller, I caught that exception. Now I could then just type in throw and rethrow this exception up to the next level. But in this case, the next level is pretty much I don't even know what it would be. But then if I throw up to the next level, it's going to crash because nothing else is trying to catch it. So by doing it this, I rethrew it. Now, one thing to note with doing it this way is by doing a rethrow like this, it does not modify the call stack. So the call stack will stay intact when I throw this. It's kind of like this throw didn't even exist. Okay, so just remember that if I'm inside of another catch, I can just say throw like this. It throws it up to the next level. So whoever was calling main would now receive this. But in this case, it just crashes. Alright, there's a couple other things I'm just going to talk about. I'm not going to show because it's hard to in this example. Let's say 1-96 talks about throwing a new exception that points to the original one. So if I'm rethrowing the exception, what I want to do, let's say an exception was thrown, but I want to maybe take that information, plug it into a new exception, and rethrow it. Because maybe something else happened or something like that. I don't know, whatever the situation is. In this example, if I want to throw a new exception, there is a constructor that allows me to pass in an older exception. So if I'm in a try and catch like this, and I wanted to throw up another one, I could throw new I don't know, exception blah blah blah, and I could pass in this argument null exception here. So when I throw up to the next level, that exception that I passed into the constructor will be stored in the inner exception of the new one, so that the caller who got the last exception can look at all the exceptions. They can see the first exception, the second exception, and things like that. And by doing this, the book puts it this way, that you don't swallow any exception details by rethrowing the exception. So by doing it this way, you won't lose any of the details of any older exception or anything like that. It just keeps on pointing to the next one. So you could keep on pointing them. It's kind of like a linked list, sort of, you could think about it. But it will keep on pointing to the next, or the previous exception. So by doing it like that, by passing into the constructor the old exception, you won't lose any exception details. Now, in listing 1-97, it talks about this exception dispatch info dot throw. Now, this is really simple. I mean, it's just another thing that this was actually introduced in C#5, and by doing this, you're allowed to throw an exception, but by doing it this way, you preserve the original stack trace. And we remember what the stack trace was. I showed you what that was. So by doing it this way, you could preserve the original stack trace. Now, this also is used for a couple of other things. You don't have to do it inside of a catch, and you can throw an exception. But however, this was introduced in C#5 for the use of async and the await features, because this can be used for multi-threaded programming, because we can throw an exception onto a different thread. And that was really the main purpose of creating this. Although it keeps the original stack trace, and that's important because if we're throwing between different threads, we want to keep that original stack trace. But yeah, pretty much this feature, I'm reading this, it says this feature can be used when you want to catch an exception in one thread and throw it onto another. And like I said, .NET Framework uses this when dealing with the async and await feature added in C#5. An exception that's thrown on an async thread will be captured and rethrown on the executing thread. So that's what this is really used for. And that is listing 1-97 using exception dispatch info.throw. Okay, I want to talk about really quickly on page, I don't know, this isn't a listing, right above table 1-4. The author talks about something that's really important about exceptions. And what he talks about is when you shouldn't use an exception, right? The only time you should really use exceptions is, when an unexpected exception happens, right? You shouldn't be throwing exceptions that are dealing with expected things. Like, if you know that this is going to throw an exception every single time, you shouldn't prepare and throw an exception. The proper things to do are to use a concept called validation. Now, instead of just throwing an exception, like in this case, we could just do some validation. We could do, actually we kind of did some validation, but pretty much the concept of validation is to just check. Do some checking and say, okay, if a user enter in some input that you don't want, you could do some if statements and do some checks and say, is this what I want? If it's not, you can just send a message back to the caller and say, oh, bad, invalid input, etc., etc., etc. To actually create an exception and throw that exception, there are some performance hits with that, and the book shows you some of them, but obviously, one is memory. 2 is when you throw an exception, it has to search for the next catcher, which takes some time and things like that. And the book, I don't know if the book might go over a few of them. I didn't really read it that much. I'm not sure, but yeah. So it's important to do validation first before you throw an exception. If the error is expected, don't just throw an exception every single time that happens. Try to write some code that can validate that, and maybe just send a message back to the user that maybe is more informative and things like that. So it's not always the best thing to just throw exceptions over and over again. Sometimes you want to do some validation and things like that. So validate before you throw an exception. That's what you want to remember. All right. Actually, this is pretty short. I didn't realize that it was this fast, and I'm pretty much just going to talk about the last thing because I'm not going to really go into it. It's basic stuff. You're going to look at it, and if you really want to do this, then you can. It doesn't really come off. I don't really do this that often. So the last topic in this lesson is creating custom exceptions. Now I'm just going to quickly talk about what this means and why we would want to create a custom exception. The first thing to note is if we create a custom exception, you have to inherit from system.exception. All exceptions must inherit or should inherit from system.exception, and you need to provide at least a parameter list constructor. So just that, you could create a custom exception. I'm pretty sure. Yeah, that's it. Okay. So now, why would we want to create a custom exception? And this is really only useful with a couple reasons. It's only useful if your developers that you're working with, or you or other people that are looking at your code know what exceptions these are, and if they make sense to them. If they don't, it's just going to make it more confusing and things like that. But a reason why you would want to create a custom exception is because it's more specific than system.exception, and that you could specify a more specific error. So, maybe something really specific happened, like, for instance, a user, I don't know, logged in or had 5 incorrect password attempts when logging into your program. Okay, throw an exception. This is all hypothetical, by the way. That's a very specific error, so I could create an exception that says that information, has all information about that exception, and if that happened, I could throw that exception up to the caller. But like I said, the caller has to be, if it's a different developer or something, they should be wary about, okay, this custom exception exists. I need to know what it means and how to handle this exception. So that's really, that's really the best time you would use a custom exception, is if you want to specify with a lot of detail, like this is a very unique, very specific exception, then I could create a exception for myself, and a custom exception for myself. So with that said, yeah, there really isn't that much code involved with this lesson. Most of it is just me talking, and it's only about 30 minutes long, so this isn't that bad. I might have missed a couple small things here and there, but ultimately, exceptions aren't the hardest topic to understand. It's just a topic that you should just be aware about. For the most part, being able to catch exceptions and rethrow them, that if you got that, then you're good to go. So, yes, this is objective 1.5, and this is the last objective in chapter 1. The next chapter is going to be chapter 2, and we got 7 objectives in that one. Just quickly go over it. Chapter 2 is creating and using types. So objective 2.1 is creating types. 2.2 is consuming types. 2.3 is enforcing encapsulation. 2.4 is create and implement class hierarchies. 2.5 is find, execute, and create types at runtime by using reflection. That's a big thing. 2.6 is manage the object life cycle. And 2.7 is manipulate strings. So that's what we're looking for. Or that's what you have to look forward to in the next chapter. Once again, creating and using types. So that's what I'll be getting into now. So this is the last one of of chapter 1. This is the last objective 1.5. And like I said, there wasn't that much code. I didn't write that much code for you guys. Most of it was just me talking. But you could look at the code in the book, and it's not really that important. The code's there. But I showed you pretty much the important things that I personally think are important. So, with that said, I hope you guys enjoyed this video, and I'll see you next time.